Alright guys and gals, let's take a quick look at work and energy. We're just looking at the types of work and energy that we're going to go through and the equations for these types. Energy is the capacity for doing work, so they're usually used interchangeably. It can be in many forms such as kinetic energy, gravitational potential energy, elastic potential energy, electrical energy, thermal energy, and nuclear energy. So whenever you hear me calculate the work done or calculate the energy, pretty much asking you for the same thing. First, let's look at kinetic energy. Ke equals half mv squared. What does this even mean? Kinetic energy is moving energy. If something is moving, it has kinetic energy. Every object has a mass, and anything that moves has a velocity. So if something is moving, it has kinetic energy. Factors that affect kinetic energy are mass, the m is mass, and that's measured in kilograms, and velocity, which is the v there, and is measured in meters per second. Mass is directly proportional to Ke. When mass goes up, Ke goes up, while velocity has a squared relationship. When velocity goes up, Ke also goes up, but it goes up squared. So if I increased my velocity by a factor of 3, my kinetic energy would increase by a factor of 9, because you have to square that 3. Whereas with mass, if I tripled the mass, I would triple the kinetic energy, considering the other one is the same. Now let's look at GPE, gravitational potential energy. It's considered to be the potential for an object to do work based on height. If an object is raised a certain height, you have either done work in raising it that height, or you could say that it has the potential to do work from that height. So GPE is equal to mgh. M is a mass, measured in kilograms, directly proportional to gravitational potential energy. G is gravity. It is a constant. It's usually 9.8 meters per second squared, since most of the problems are done on Earth. This only changes when we calculate GPE outside of Earth, and it's directly proportional to GPE if you do change it. So if I doubled gravity, then I would double gravitational potential energy. If I halved gravity, I would halve gravitational potential energy. Height is the distance from some reference point considered to be 0, usually the floor. It's directly proportional to GPE. You increase the height, you increase your energy. Alright, this one is elastic potential energy. You're going to see me put it as PE, elastic. Depending on what source you're looking at, you might see it referred to as ELPA. So that's elastic potential energy. It's 1/2 kx squared. What is elastic potential energy? It's energy stored by a stretch or compression. So whether it's a rubber band or a spring or anything that you can pretty much squeeze and it tries to get back into shape, or stretch and it tries to get back into shape, it can give you elastic potential energy. The factors that affect elastic potential energy are the spring constant, K, which will be in newtons per meter, and displacement, X, which will be in meters. Displacement is basically how far you are away from rest position. So if you can picture a spring, the spring not being stretched or compressed would be considered 0. Once you compress it, the amount that you move the spring, that would be X. Or if you stretched it, the amount that you stretched it, that would be X, your displacement. The spring constant is directly proportional to the potential energy, while displacement has a squared relationship, much like velocity when we were looking at kinetic energy. If I increased it by a factor of 2, then you'd be increasing your elastic potential energy by a factor of 4, because 2 squared is 4. So on and so forth. We can also look at work done as W equals FD, force times distance, which is pretty much where all of these equations came from, is some version of this. This only works when the force is in the same direction as the displacement. Alright? Now when I say same direction, that means that work is done if my force is being applied to the right and my distance is either left or right. If they're in opposite directions, such as friction, then the work done will be negative. But if my force is going up and my displacement is going to the right, then that means that that force is not doing work. There's some other force doing work. Also, something is moving at a constant velocity or is not moving at all. That means that work is zero. Because if it's constantly moving, that means that acceleration is zero, which means your net force is zero. And if it's not moving, that also means your net force is zero. Even if you're applying a force to it, your net force is zero. Alright, so you have the equations. We're going to follow these 5 basic steps when you get these word problems asking you to calculate energy. First thing we're going to do is understand the problem. What is it asking for? Be sure to use units as clues to what info is given. Is it giving you distances, masses? Is there a spring constant somewhere in there? Does it have friction? All that stuff. Pick your equation on the types of energy. So, does it say that it's moving? If it's moving, then it's kinetic energy. That means you have to use half mv squared. Is there a spring somewhere in there? Because if there's a spring in there, then you might have to use half kx squared. Does it mention that something is lifted to a height or something is already at a height and it wants to know the potential energy? Then you have to use mgh. Pick your equation based on the types of energy that you come across. You're going to substitute variables in the formula with the corresponding numbers in the question. So if they're asking you to find gravitational potential energy, more than likely they've given you a mass, you can assume gravity, and they've given you a height. If they're asking you to calculate the speed of an object, more than likely they've given you the kinetic energy and the mass. That way you can solve for V. Solve for the missing variable using algebra. Don't forget good old paper and pencil to help minimize mistakes. I know a lot of these questions are on the computer screen, and a lot of us like to just look at the computer screen and try to plug stuff in the calculator. If you have to solve for something, just use some pencil and paper, pen and paper. Alright? Don't try to do it all in your head. Write stuff down. Check the problem again to make sure that you have answered the question, you've answered what the question is asking. Alright? Okay, I found velocity. Is the question asking me for velocity? Okay, I found energy. What type of energy did I find? Did it ask for that type of energy? Just check.